Last video, I proved the first kinematic equation that the final velocity is equal to the initial velocity plus the acceleration times the time. But what if we're not given the acceleration? In this problem, a car is initially traveling at 10 meters per second. At time is equal to 0 seconds, the car accelerates at a constant rate, which we don't know. At time is equal to 10 seconds, if the car is going 15 meters per second, how far did the car travel? So we're given the initial velocity, the final velocity, and the time. And we're asked to find the displacement. Let's draw a velocity versus time graph. So this is going to be velocity as a function of time. So it starts at 10 meters per second, ends at 50 meters per second, and it takes 10 seconds. So time is equal to 0, or this is 0 seconds. Starts there, and it ends at time is equal to 10 seconds at 50 meters per second. And we know it has to be a straight line because the acceleration is constant. So how will this help us? Well, if you remember, the area under a velocity versus time graph is actually the displacement of an object that undergoes that motion. So this area is the displacement of the car. And if you didn't know this fact, watch this video above to see why it's true. So all we have to do now is just find the area underneath this line. And if you think about it, this is actually just a triangle plus a rectangle in disguise. The area of the rectangle is just the base times the height, so 10 seconds times 10 meters per second, plus, and the area of the triangle is 1/2 base, just 10 seconds, times the height, which is not 50 meters per second, but 50 meters per second minus 10 meters per second, which is 40 meters per second. And this, once you simplify it, is equal to 300 meters. So the car traveled 300 meters. But what if you're not given numbers, but instead variables? So the car is initially traveling at not 10 meters per second, but at v0. At time is equal to 0 seconds, the car accelerates at a constant rate. And at time is equal to t, if the car is going at not 50 meters per second, but v final, we're asked to find how far the car traveled. Just like before, we're given the initial velocity, or at least in a variable form. We have the initial velocity, final velocity, time. We're asked to find the displacement. Well, we can actually do the exact same technique. So instead of 10 meters per second being the initial velocity, we just call that v0. This is v final. And instead of 10 seconds, it's t. And no matter what initial velocity you have and what final velocity you have, and whatever time you have, whichever time it is, it can always be split up into a rectangle and a triangle. The area of the rectangle is just base times the height, or v0 times t, and the area of the triangle is 1/2 base, so time times. This is actually not v final, but v final minus v0. And this simplifies to time times v0 plus v final divided by 2. And since this is the area underneath the velocity versus time graph, this is the displacement, and so is this. So we've just proved the second kinematic equation.